I've read every theory on how they built those pyramids. The Great Pyramid of Giza has 2,300,000 stones in it. Some of them weigh between 2 and 80 tons. Some of them are caught from a quarry that's hundreds of miles away. These things point, that pyramid is shaped perfectly. Like if you're off like a quarter inch there, a half inch here, by the time you get to the top that thing's a mess. But meanwhile it's not, it's perfect. It's also perfectly aligned to true north, south, east, and west. And they're not really sure how old it is. They date it to 2500 BC, but that's just because of organic particles that they pulled from inside stones. But they also say that they probably could have sealed those stones and resealed those stones over time. You're dealing with like a gigantic mystery of unfathomable proportion. That's crazy. Let's go to the pyramid itself. So you have a very fascinating hypothesis as to what the pyramid or theory as to what the pyramid actually was. And it's based on where the supposed king's chamber is, where those passages go through into it. And what do you think that thing was? Well, my first book pretty much describes what I thought it was in 1998, which was a power plant. It's entitled The Giza Power Plant. My second book has evolved and I describe it as an electron harvester. So, it's kind of like you could describe it as both. But in today, when you do, or people, in any decade they think of a power plant and they see these huge chimneys with smokestacks or a nuke plant. Yeah, or a nuke plant, oh, power plant, dirty, nasty, unclean. Mitchum. But an electron harvester, clean, pollution-free, not a problem. Has that been achieved conventionally? I mean, today is there a thing called an electron harvester? I think that actually when you look at a generator, that's an electron harvester. Because we don't create electrons, we just harvest them. It's just how we do it. And so, when you say an electron harvester, you could say that, say a wind gen, you have a windmill, you have a generator inside, and then you're collecting electrons off the commutator in a generator. And that's where the electricity comes from, and that's your electricity. Right. Or hydroelectric, you use the flow of the water. Yeah, you don't create them, you just release them. You harvest it from a process. You harvest them through a process. And the process that you think they used in the Great Pyramid involved those shafts? It involves a lot of things. Yeah, it's not just one single thing. It's a system, not a single thing. So when you look, we show a photo of that. Do we have a photo of the pyramids and the shafts and where the king's chamber is? I know you've described this before. Mitchum. Do you have a photo of? I do. Cindy, I was trying to figure out which one you want. Okay, perfect, this works. Yeah, that works. So these names, the king's chamber and the queen's chamber, you don't think that that's actually a king's chamber or queen's chamber. You think it's something else? Well, out of respect to the Egyptians, what they call them. Yeah. But I do have a different terminology for them as they function. Now, the initial surface of the Great Pyramid is covered in smooth limestone, right? So it's polished and shiny and apparently it would collect insane amounts of light. Well, the outer surface of the Great Pyramid mostly is missing, but it has been described as if it was finished, and depending on the polish that it received, yeah, it could reflect a lot of light. Do you think that had something to do with the design of this power plant? I don't think there's any part of that pyramid that did not serve a practical function. Okay, so this is the image that you have here. And what this image shows us is the king's chamber, the various shafts, the southern shaft, the northern shaft. And these shafts have been described as portals to stars because people have looked up through there and you go through the shaft you see stars. But what you're saying is something entirely different. What do you think these shafts were for? Well, I think they serve two different purposes. Actually 4 different purposes if you will. Because in the theory that I propose, which is, I don't know, it's a speculation, well, the whole process is kind of like a humoristic process where you're grabbing information, you're moving here. It doesn't matter what source you're getting it from, right? Because when you are looking for answers, you look everywhere. You try and find, you look everywhere. So when I was going through the process of trying to figure it out, I was collecting information from and one of, for the southern shaft and the northern shaft of the Queen's Chamber, that was a huge mystery to me. And I tried to fit it into what were they doing? I mean, if you look at the details, the facts of their design and what the ancient Egyptians were doing, why they designed them that way, you have 2 conduits coming into a chamber but they're not connected to the chamber. And we didn't even know they existed until 1872 or, for Wayman Dixon. Can you show me that image again, please? So they're coming into the chamber but they don't enter into the chamber. So they stop. Their original design had them, the shafts, ending 5 in before coming into the chamber. So you had 5 inches of limestone that was left in the block. So did someone remove that limestone? Yes. Why did they do that? Wayman Dixon. because they were examining the chamber and they were poking around, and Wayman Dixon, it is reported, so the legend goes, noticed a crack in the wall. And so he took a rod and pushed it through the crack in the rod. He didn't meet any resistance, he kept going. So he had his worker come in, Bill Grandy, with a hammer and chisel and say, chisel the limestone around there. God, people are stupid. Well, they didn't have ultrasonic thickness too. No, but still, goddamn. To have the arrogance to go and chip away at the pyramid because they're curious. Look at how, I don't care for revisionist historians. Because, you have to consider what people were doing, their mindset in the day. And then I try to look on the bright side. Right? It's like, I don't look at it as a negative thing because if somebody hadn't opened up those shafts, we wouldn't know about them. Right? And it's the same with the chambers above the king's chamber. Without Howard Weiss and his military expedition blasting his way up into the pyramid, we wouldn't know about them either. There's a lot there. I think there's a lot there right now and it's been investigated now. But there's things that have been revealed through scanning like muography, the Muon Scan Pyramid Project. And they found that large void above the Grand Gallery. Right? And so, which is larger than the king's chamber. Right? It's longer than the king's chamber. Yeah. And so that's not even represented here on this. It's about the size of the cabin on a Boeing 707. Wow. So if these shafts came through and then they met limestone at the end, what do you think was going on? In order to answer that question, I had to look at the rest of the pyramid. Okay, what was it doing and how was it functioning? And so one of the key pieces of evidence that I used to propose a process that was going on is the northern shaft. And the northern shaft has dimensions and has an appearance that is similar to a waveguide that you would use for microwaves. And the dimensions of it would be approximate to the wavelength of hydrogen. So explain a waveguide. How does that work? Yeah, it's like, a waveguide is to transmit microwaves, electromagnetic energy, in the microwave region. And it is passed more efficiently through a tube or waveguide. And that's what they use. They're very complicated systems. And so how did this represent in your mind what a waveguide looks like? Actually, the idea of a waveguide came to me from a guy. We were talking about the pyramids and I used to carry a schematic of the Great Pyramid in my back pocket. And I'd meet an engineer and I'd go, hey, come here. Start going through. So what do you think about this? Because, I was looking for answers, suggestions, brainstorming, anything. Right? And it's like, so these shafts right here. And he looks at it and he's into electronics, IIC engineering. And he's like, they look like waveguides to me. And I thought, well, that's interesting. They look like waveguides. Okay, what if they are waveguides? How did they function? What would they use waveguides for in ancient Egypt? And so I started to go down that rabbit hole. And that led me to the Queen's chamber. I said, okay, waveguides. You need a medium. You need microwaves to go through a waveguide. What frequency of microwave was it? Right? And you look at the dimensions and you come up with a match for hydrogen. How do you do that? How do you come up with a match for hydrogen? Through the dimensions? Yeah. The wavelength of hydrogen is 8.309 inches. And the width of the northern shaft is 8.4 inches. And a waveguide generally has the wavelength and then about half of the wavelength in height. So it's a rectangular shaft? Just like all the shafts are, right? Yeah. And, well, the Queen's chamber shaft is a little more square than the King's chamber shaft. So had a different function? Different function, yeah. So these waveguides, you believe what are they collecting and where are they getting it from? Good question, Joe. We are bombarded with microwaves every day. It's the signal from, they say, the Big Bang. And, it comes from atomic hydrogen out in the universe in outer space. So we're being bombarded and you believe these passages were collecting this? Yeah. So then you say, okay, if we build a device and we want to energize hydrogen, we bring it to a higher energy state, just like, in a laser where you have microwave amplification through stimulated emission. Right? So if we want to collect energy that is in a gaseous medium, say that is hydrogen medium, and the electrons in the hydrogen are pumped up to a higher energy state, and we want to collect the energy in that, introduce a microwave signal, direct it through that gas and stimulate the emission of the energy, collect that energy and shoot it up the southern shaft. And so that was like, okay, that might work. So what kind of gas? Hydrogen. And so where are you getting the hydrogen from? Queen's chamber. So there's hydrogen in the Queen's chamber. And how does it get in there? The shaft. But it doesn't come in as hydrogen? That's part of the theory in the Giza power plant. There are two chemicals that are introduced into the chamber and the chemicals mix and they boil off hydrogen. And these chemicals are just coming from the radioactive waves of space? No, no, no. The chemicals, I believe, are manufactured and delivered to those shafts and come in. Okay, so they add some sort of chemicals to it? Same old thing. No usual thing. I will never dream of your love. You take me there. You take me there.